Hey everyone, today we are going to solve the first problem in our dynamic programming interview preparation series, which is Fibonacci number or Fibonacci number, whatever you say. LeetCode 509. In the problem statement, the Fibonacci number, commonly denoted as Fn, form a sequence called Fibonacci sequence such that each number is the sum of two preceding ones, starting from 0 and 1. And this is the formula given to us. And we are given a value n. We have to calculate the value of f of n. And the formula given to us is that for f of 0 we already know, f of 1 we already know, and for every n value what we can do is f of n minus 1 plus f of n minus 2. If we straight away going to implement this function, what will be our code? Fibonacci int n int if n is less than 1 return n. This is going to be our base case, that for every n less than equal to 1 we are going to return n. Otherwise we are going to return Fibonacci of n minus 1 and n minus 2. This is going to be our recursive approach. So let's take an example where we have to calculate the value of f of 5. So f of 5 will be calculated from f of 4 plus f of 3. If we further solve the f of 4, which will be equal to f of 3 plus f of 2. F of 3 will be equal to f of 2 plus f of 1. F of 2 will be equal to f of 1 plus f of 0. This is our base case. This is our base case. We are going to return n. That is 1 from here, 0 from here. Now we are at here, and f of 1 is also a base case. We are returning from here. And from f of 3, now we'll solve this call f of 1 plus f of 0. Both of these are our base case. Now we are at f of 3. From f of 3 we are going to solve f of 2 and 1. From 2 we are going to solve f of 1 and f of 0. Base case, base case, base case. Okay, now our recursive call is finished and we are having the value of f of 5. From our terminating case we are returning 1, 0, 1, 1, 0, 1, 0 and 1. So value of these two things will be equal to f of 5. Here we have something to analyze, that first of all we calculated this f of 2, and after that we again calculated f of 2, and then further we calculated f of 2 in our function call for f of 5. If we have a look at f of 3, f of 3 is also calculated twice. So here it calculated the f of 3 value, and then when it reaches here, it is calculating the f of 3 value again by making all the subsequent calls. So here, firstly what we did, first of all we solved our subproblems. For 5 we have to calculate the value of 4 or 3. For 4 we have to calculate the value of 3 and 2, like this. So f of 5 is a bigger problem, f of 4 is a smaller problem. So this is going to be our subproblem. This is our big problem and this is our small problem of same type. So this is what we call subproblems. And after that what we analyze is there is the overlap in the subproblems. The second thing that we observed is that we are having overlapping subproblems. So these two are the same problem and they are overlapping. We are calculating those two subproblems again and again in our program. So we are having overlapping subproblems in our recursive solution. So we straight away did the recursion and we found out there is overlapping subproblem. So how do we fix that? Let's see. At this position, if we have already calculated the value of f of 3, then what is the need of calculating it again at this position? Why don't we just store it somewhere and then reuse it at the later calls? Okay, if there is a way, let's say we are using a map for call 3, we have our answer, and then when we reach here we will see whether there is an entry for 3 in the map or not. If there is an entry, we'll just directly going to capture the answer. So that is going to be O1. In a constant time we are solving this problem again. So we have solved all of our overlapping subproblems. So this is what we call memorization. So if we implement this memorization in our recursion function, this will become recursion with memorization, which is called DP, dynamic programming. Now we have two main points. Like first of all, we need to see whether there is any overlapping subproblem or not. If there is any overlapping subproblem, we will solve the problem recursively, but we will keep on memorizing those subproblems. So this is what we really call DP. So here in this function, if we are calculating f of 3 and then along with that we are memorizing it somewhere. So whenever it is going to be called again, it will be in a constant time solution. So for f of 3 we are calculating here, f of 2 we are calculating here. So for every other call of f of 2 we are just getting the answer from our DP or maybe our storage. So in our previous solution we are returning from our base case if n is less than or equal to 1, otherwise we are making a recursive call to f of n minus 1 and n minus 2. But here we will keep on capturing it somewhere because this is the answer of n, and we are capturing it against dp of n. We are having values from 0 to 30 in our problem statement. So let's say from 0 to n we have the number of inputs. We are storing values for each of the problem till n. So we can have a dp array of size n plus 1. And before returning this solution, we are going to store it. And before that, we will also check. But before that, we will already check whether we have already pre-computed it or not. dp of n not equal to 0. In that case, there is some value under dp of n. That is our answer. Return dp of n. So in this way, we have memorized our solution and improved the time complexity. So here we have our bigger problem and we have solved that problem by solving smaller problems n minus 1, n minus 2 and so on till we reach our base case 0 and 1. So this is called top-down approach using memorization, or you can directly say top-down DP using recursion with memorization. There is also one approach which is bottom up, where we generally solve smaller problems and then reach till bigger one. So for 0 we already know the answer, for 1 we already know the answer. Now we will solve for 2 and then 3, then 4, like this iteratively. For 2 we already have the answer of previous two variables, which is 1. For 3 sum of previous two, which is 2, like this. Now let's try to implement both of these approaches. First of all, let's try to write down the top-down approach in a recursive fashion. N less than equal to 1, we are going to return 1. This is our base case. For a value of n equal to 0 and 1, we are going to return n. Otherwise, we are going to return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Let's run over sample test cases. It is working fine, but if I submit the problem, this is not the fastest one because we are having overlapping some problems that we can solve using memorization. Our n value is going from 0 to 30. So we have to store the result of 30 at max. So for that, I'm going to take a DP array of size 31. And after calculating value of each n, I'm storing the DP. But before storing or calculating the value, I will also check whether we have already computed it or not. If DP of n is not equal to 0, it means we have already computed it and we can directly return it. dp of n. Let me submit again. Now this is 100% faster. So in this way, by avoiding the overlapping subproblems, we have improved the time complexity a lot. Now this was our top-down approach. Here, let's have a look at the bottom-up approach for this problem. Bottom-up approach. In the bottom approach, first of all, we will just calculate the value of smaller problems 0, 1, 2, 3, and then we will go till the bigger one, n. So to solve any value, let's say for n equal to 3, we only need the solution for previous two problems. So to store those solution, we can take two variables, previous or previous to previous. Our base case is n is less than equal to 1. We are going to return n. That's all. So now we can easily solve it for values n greater than equal to 2. Let's say int previous is equal to previous one is storing the value of Fibonacci of 1, which is 1, and previous of 2 is storing the value of Fibonacci of 0, which is 0. Let's also take a current variable. Now we can directly go from int I equal to 2 to I less than equal to n I plus plus. Now for every value of current is equal to previous one plus previous 2. Now we can move further if we want further iteration. So previous 2 is going to have a value of previous 1, and previous 1 is going to have a value of current, and ultimately we can return the current value. So for n equal to 0, we are going to return 0. N equal to 1, we are going to return 1. For n equal to 2 onwards, we are going to return the value of previous 1 plus previous 2. And we will keep on updating those two variables. Let's try to test our sample test cases. Working fine. If I submit the problem, it is also 100% faster. Okay, hope you understood the both of the approaches. If you have any issue, you can comment down below. I will be happy to help. Thank you guys. Bye bye.